Everyone, welcome back to this machine learning playlist, and this is day 19. In the past few videos, we have looked at how images can be classified with HGD classifier, and MNIST dataset was one that we used, right? So there might be other datasets also that you can explore. Maybe in next few videos, we might also come across load digits is another dataset which is of much smaller width and height. So we will come across that as well. Please do explore more on image classifier techniques in machine learning. The more the interest, you would explore more opportunities outside, right? So yeah, and have some comments or any thoughts that you would like me to explore or would like me to talk about more in these videos as well, right? All right, so in this day 19 we have performance measures. So we have looked at an introductory session on how a classification of digits of an MNIST handwritten digits specifically is classified with 0 to 9. So in this one we are going to be looking at how they are classified and how much of a precision they have, right? And few things that we are going to be coming across is terms like true positive, true negative, false positive, false negative, and how we interpret the results with confusion matrix, and how we build a confusion matrix at the first place. So just take a simple example of true positives being 111 as something like a array of this, and predicted values being something like this, where you see one being predicted as 0 and 0 being predicted as 1 sometimes, right? Just take it as an example, just to understand how confusion matrix works. So to draw confusion matrix, we pass these two arrays into the confusion matrix method that we imported from sklearn metrics, and we get such a array. So we could see that the diagonal values are correctly predicted values, and the others are either true positive, false positives or false negative values, right? So yeah, and also interpretation for these false positive and false negatives. So true negative is correctly predicted negative, and true positive is correctly predicted positive. Let's say we ask for one, it says it's one. Let's say if we ask if it is not one, it predicts not one. Or let's say we ask for one, and if it predicts zero, saying uh, 0 is 1, then it is predicted positive but a false result, right? So that's false negative. And uh, let's say we send a 0 and say ask if it is 1, then if it says positive, then it's a false negative, right? Slightly tricky wording here, but yeah, I hope it should make sense. And next is precision. Precision is nothing but how much of a accuracy a specific model is giving us. For example, we have true positives in this case. We have about two values which are not being predicted correctly, the ones that we see here and here. So precision gives us total positives by true positive minus false positive. So it's about 80% where two are not being correctly measured. In case of recall, uh, we can see that it's true positive by false negative, and it has about 80%. So um, here, of all predicted values, how many were correct is a answer that precision gives us. In case of recall, of all actual positive, how many were found positive, right? So that's the information that gives false positive and false negative here. So F1 score is slightly tricky. So it's something like this, right? Know that F1 score is very useful, and it gives both precision and recall in a single formula. And decision threshold is another parameter that we also use in performance measures. It helps us understand how accurate a model would perform with unknown set of data, right? So let's say we are given with these set of values and a default of zero point 0.5. Let's consider that. And if there is more of a threshold, then we get much higher predicted values. For example, You see here 0.7 being a higher threshold than zero point 0.3, and precision also being increasing, right? So that's one thing to observe. So lower threshold means higher recall. Higher recall means the values are predicted a lot more accurately, and higher threshold means fewer positives predicted, right? So that's one thing to understand. Okay, so yeah, so these were about decision threshold and parameters like F1 score, precision, recall terms. So yeah, and next thing is all of these are part of performance measures, and we might come across them. Just keep a uh, brief idea on what all of them are, right? That's it for this video. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.